Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so we have been discussing about the chapter light, and we have been specifically discussing about the phenomenon called refraction. So already we have uploaded some lectures where we have discussed about the fact or about the phenomenon of refraction. We have also discussed about the prism. Okay, so now we will be moving on to the next part. So what is the next part? Let us see. Okay, so as you already know what is refraction, then we have also seen refraction through a prism. Today we will be mainly discussing about the shift, okay, or we will be talking about the real depth and apparent depth. Okay, so why this real depth and apparent depth, concept of real depth and apparent depth comes into play. See, so today we will be talking about real depth and apparent depth. Real depth and apparent depth. Okay. So real depth and apparent depth. What is this concept? First, let me briefly talk about it. Real depth and apparent depth. Okay. So what is the concept? See, I think all of you have seen that the swimming pool appears to be less deep than it actually is. What I am trying to say is that when you see at a swimming pool or see at a pond, you will see that the basement of the swimming pool or the lowest layer of the pond seems to be raised up a little. Why this happens? Try to understand. Or you may have also seen that if there is an object kept at the bottom of a tumbler in which water is present, you will be noticing that the object seems to be slightly raised up. It does not seem to be at the bottom of the tumbler, or rather the base of the tumbler is a little bit upward. Okay. So if I try to explain this concept, let me just draw a figure. See, if I consider a vessel containing say a liquid, say water, we are taking simple water. Okay. Now if I consider this vessel now, and there is, I am saying that water is present in this vessel. So water is present in this vessel like this, fine. So up to this layer water is present, fine. Now what happens if we see an object placed at the bottom? What will happen? Say if I consider there is a coin kept at the bottom of this vessel. Coin kept at the bottom of this vessel. So what will be happening to the rays of light that are being reflected from the coin? Let us see. Say we are considering two rays. One, if I consider that it is coming out perpendicular, then it will obviously move out perpendicular to the surface of the water like this. It will just move out without being refracted, isn't it? If I consider another ray which is not coming perpendicular to the surface but it is slightly bent in this way, and if I draw the normal at the point of the incidence, if I draw the normal at the point of the incidence, so here is the point of incidence and this is the normal. The green dotted line is the normal. Now what happens? The light ray bends. As it is coming out from water to air, the light ray bends and it goes out in this direction. Okay. So if a person is seeing this from here, say a person is seeing this from here, what he or she will see is that the coin seems to be raised. Why? So this will be something like this. The ray will be intersecting here. Okay. So we will be seeing the image of the coin not at the bottom, rather here. Okay. So I think the concept is clear. Okay. So now see, we have diagrammatically explained why this phenomenon is happening. So I think you can very easily understand that this phenomenon is actually due to refraction of light, isn't it? Refraction of light. So obviously diffraction causes a change in the depth. It is not actually happening, but rather it is a illusion. Okay, so rather you can say that this is an illusion. Fine. So this is an illusionary thing that is happening here, that the bottom of the vessel seems to be raised, or any object kept at the bottom seems to be raised. Okay, so this is due to refraction. Now if I consider what is the real depth of the coin here, the real depth of the coin is this, it is kept at the bottom, so real depth is this much is the real depth, isn't it? This much is the real depth. And what is the apparent depth? If I say the apparent depth, so it will be this much only, isn't it? It will be this much. So there is a difference between the real depth and apparent depth, and this is called the shift. And we are not going to mathematical derivations, as this is not included in the syllabus. Just we are noting down the formula that the real depth and apparent depth are related to each other as, if I say that the mu is the refractive index of the water, the denser medium water, then mu is equals to real depth by apparent depth. So this is our formula, apparent depth. Okay, so this is the formula. So in all such cases, the actual phenomenon responsible for such illusion is the refraction. Now if I consider what is the difference between the real depth and the apparent depth, and that is called shift. What is the difference between the real depth and the apparent depth? It is actually called the shift. So it will be equals to real depth. If I consider, say, the real depth to be x, if I consider the real depth to be, say, x, okay, and the apparent depth to be, say, y, okay, the apparent depth is y and the real depth is x. Okay, so what will be the shift? It will be real depth minus apparent depth, isn't it? It will be real depth minus apparent depth. Definitely yes, definitely yes. Now we can write this as x minus y, isn't it? We can write this as x minus y. Now from this formula, can you say that apparent depth y is equals to real depth by mu, real depth by refractive index, isn't it? So we can write, okay, so let me write it here. We can write that the shift is equal to, okay, just let us shift a bit to the left, it will be easier for you to see. We are taking it to here. Okay, so shift is equal to real depth, so it's x minus apparent depth y. Now you can see apparent depth is equal to real depth by refractive index, so it is x minus x by mu. So if I take the x common, so it will be x into 1 minus 1 by mu. So this is the formula of shift. Okay, so this is the formula for shift. So I can say that shift is equal to real depth into 1 minus 1 by refractive index. So this is the formula for shift. Okay, so I think the concept is clear. Okay, now you can actually try out this experiment. If you take a, say, container or say a bucket, okay, of certain height, you keep a coin at the base of the bucket. Now you start moving back a little bit. After moving back a certain distance, you will not be able to see the coin at the bottom. You stand there, ask your brother or sister to pour some water into the bucket. Now when your brother or sister pours the water, please notice that the coin remains at the bottom of the bucket. It does not come up with the water. Even if the coin is at the bottom of the bucket, you will be noticing that after pouring a certain amount of water, you will be able to see the coin from the very distance from where you were not able to see the coin previously. So this actually is happening due to this phenomenon. When you pour water, the light gets refracted, and from this position, see, if there is no water, you will not be able to see the coin, as because the light is not traveling to your eye. But when water is poured, the light gets refracted and you can actually see the coin. You can try out this experiment in your home. Okay, so please do the experiment if possible, and don't forget to mention it in the comment box. We'll be happy to see your read your observations. Okay, now So this is the concept of real depth and apparent depth. Okay. Now there are many consequences of this phenomenon of refraction, and some of the phenomena are twinkling of the stars. You see, when light comes from the stars, they travel a long distance. When they enter the atmosphere, the different layers of atmosphere have different densities. Hence, they keep on refracting light in different ways, and also the density of the atmosphere actually changes with temperature or time. Okay, please, if you are noted the problem, please pause the video, move back a little, and please note down the concepts or note down the formulas that I have written. These are important as because this will help you to understand the theory in a more clear way. Okay, so there are certain consequences. As I was saying, there are certain consequences of this refraction. Mirage in the desert is, have you read about mirages in the desert? In the desert there are no water bodies for very long distances, but sometimes to the travelers there seems that there is a water body nearby, and when the travelers go near to that point, near to the spot, they find out that there is no water. It was just an illusion. So that is called mirage, and that also happens due to refraction. Okay, so there are various phenomena. Okay, now we will be moving on to the next topic. The next topic is we will be discussing about total internal reflection. Today we will be discussing. Now next we will be discussing about the next topic. So what will be the next topic? Okay, so the next topic that we will be discussing is critical angle and total internal reflection. So what is critical angle? Let us see. Now if I consider that light is traveling from denser to rarer medium, this is the particular case that we have to discuss, that light is being traveling from a denser to rarer medium. So if I consider that light, here is the surface of separation, and light is traveling from the denser to rarer medium. So this is the denser medium, this is the denser medium, and this is the rarer medium. Okay, so light is traveling from denser to rarer. This is the consideration. Now what happens when light travels from denser to rarer medium? It tends to bend away from the normal. So if I consider a ray of light falling like this, so this is the incident ray. Now if I consider this is the incident ray, let us draw a normal at the point of incidence. So this is the normal at the point of incidence. Okay, now what happens when I consider this light ray? It will be bending away from the normal, so it will be bending like this, something like this. Okay, so if I consider this ray 1, so this is the refraction of the ray 1 dashed. Okay, fine. Now if I consider this is the angle I1, this will be the angle of refraction R1. Now have you thought that if we increase the angle of incidence to a certain more, then what will happen? If I increase the angle a certain bit more, this is the ray 2, and consider this is the angle of incidence I2, then definitely what will happen? The light ray will bend a little bit more, as because it is traveling from a denser to rarer medium, so it will move out like this, isn't it? Like this. So if I consider this is the second ray, so this is the second angle of refraction R2. Okay. Now, like this, if we keep on increasing, there will be a certain angle of incidence for which the angle of refraction in the rarer medium will become 90 degree. What will happen? It will become 90 degree. So if I just consider the incident ray to be bent a bit more, this particular angle, say I3, for this the incident ray, the refracted ray will be like this. It will just move out to the surface, and the angle of refraction will be R3, it will be equal to 90 degree. So this is the third ray. Now this particular angle of incidence where the angle of refraction in the rarer medium is 90 degree is called the critical angle, or ICE, called critical angle. So I think the concept of critical angle is clear. That critical angle, the phenomenon of critical angle is that where the light ray is traveling from denser to rarer medium, the angle of incidence is such that the angle of refraction in the rarer medium becomes 90 degree, and this particular angle of incidence is called the critical angle. Now, can you imagine if I just increase the angle of incidence a little bit more? That is, if I just increase the angle of incidence more than the critical angle. So this is fourth ray. In this case, the light will not be refracted in the second medium, rather it will come back to the same medium. So it will be just, if I consider the word bouncing back, I think I will not be wrong. It will be just bouncing back into the same medium from which it was going out, isn't it? So this will be ray number 4 dashed, and in this case it will follow the law of refraction as well, that the angle of incidence will be equal to the angle of reflection. So this phenomenon is basically reflection, and this phenomenon, while the light was being refracted, from that condition we have moved into such a condition where there is total reflection, and this phenomenon is called total internal reflection. In short, we write TIR, total internal reflection, total internal reflection, or in short you can write TIR. So the concept of critical angle and total internal reflection is clear. Okay, so this is total internal reflection. And say now you must understand that for total internal reflection to take place, there are two conditions necessary. There are two conditions. What are the conditions? First of all, light should travel from denser to rarer medium. Denser to rarer medium. The opposite case will not be like this. Denser to rarer medium. First of all, it should travel from denser to rarer medium. And second important condition necessary is that the angle of incidence must be greater than the critical angle. Only under this condition total internal reflection will take place, or TIR will take place. Why this is called total internal reflection? Total, as because you know that in case of reflection there are some part of the light that are being absorbed into the medium, absorbed on the surface. But while total internal reflection takes place, remember 100%, not even 0.1% also light gets absorbed. 100% light is reflected back from the surface separating the two medium. Okay, so this is the concept of total internal reflection that we have been discussing. So I think the concept of critical angle as well as total internal reflection is clear to all of you. On the next class we will be discussing onward, we will be talking about total reflecting prism, and we will be doing some ray diagrams. We will be seeing some uses of prisms using the phenomenon of total internal reflection. Okay, so today we will be ending our video here. Till then, please do study well, and we will be very shortly uploading the next video. So thank you, and please mention if you have any query in the comment box. We will be happy to solve your queries. Thank you. Okay.